Hello, and welcome to our final Smart Energy Summit session of the year. I'm Jennifer Kent, Vice President of Research with Parks Associates, and so pleased to be kicking off today's session. Over the next hour and a half, we are talking about distributed energy resource management, starting off with some of Parks Associates research related to energy management and particularly EVs as both a new major source of consumption and a potential resource. Then we are so pleased to welcome Greg Moorhead of GridPoint for a keynote presentation, followed by a panel discussion of industry leaders in the energy management and EV charging space. If you missed our earlier sessions, please know that you can go back and rewatch any of the virtual sessions in the Swap Card platform. You can access slides and a bunch of other materials from all of those great conversations across the year. Coming up next year, I'm very excited to share that Smart Energy Summit is an official partner with Distributech. So we will be co-located with Distributech for 2 great days of executive learnings and networking and research in February. So we certainly welcome you to submit to speak. Our call for papers is open. You can follow this QR code or come onto our website to submit to speak at Smart Energy Summit in person at Distributech in February. And like this year, we will have 3 additional virtual sessions throughout the year as we track the evolution of the industry. Always want to say a special word of thanks to our sponsors. We could not put on Smart Energy Summit without your support. Thank you to all of our sponsors who have supported us throughout the year, including our platinum sponsors, the Connectivity Standards Alliance and Rapid Response Monitoring. Thank you as well to Calix, Schneider Electric, Copper Labs, Austin Energy, Questline Digital, Google, and Residio. We appreciate your support. So if you're working in the energy space, you know there are several dimensions of change impacting the market and opening new opportunities at the same time. Solar, home storage, electrification, especially of EVs, and electrification across the home, the growth of connected home services and devices, including smart thermostats that are increasingly being called upon as an asset in load management. We'll be focusing today on distributed energy resources, or DERs, which are small-scale, decentralized energy generation and storage systems that are connected to the grid. Typically solar, wind turbines, batteries that can be used either to generate power, store excess energy, or reduce demand on the grid. You'll also hear us talk about DERMS, distributed energy resource management systems, and virtual power plants. These are platforms and assets that are helping utilities orchestrate and optimize all of these various energy assets. Solar is perhaps the most obvious DER as a generation source itself, and our data shows interest in solar is growing, with about 5 to 7% of U.S. internet households having rooftop solar today. Notably, far more homeowners are also taking battery storage with their solar installations than did in the past, which opens new opportunities for both the homeowner and the utility for more sophisticated energy management options. Beyond solar and storage, a variety of devices in the home can be called upon to impact demand on the grid, particularly when coordinated, right? So coordinated both inside the home as well as coordinated across thousands or even millions of homes in a particular area. And home energy management systems can coordinate shades, fans, smart vents, thermostats to reduce energy consumption is one example, right? And then water heaters and other appliances can be set back or turned off at certain times to help shave load when necessary. We're seeing players in the smart home and security industry certainly see potential in the energy space. NRG acquired Vivint for nearly $3 billion. ADT launched its ADT solar program. Ecobee, which has long participated in energy programs, now offers home security services by offering home sensors that coordinate with its thermostat as a hub. So a lot of crossing and blurring of the lines across energy, security, and smart home today. Certainly the thermostats have been and are the central story in the smart home when it comes to home energy management, the home energy management play. We've seen meaningful growth in smart thermostat adoption in the past 5 to 7 years. We have about 16% of US internet households saying that they own a smart thermostat at the end of last year, up from 9% back in 2015. And interestingly, and what's a wonderful result is that consumers tell us that they are noticing energy savings from these smart devices. About half of the smart thermostat owners said that they are saving as much as they expected to, that their savings has met their expectations. And another, more than a third, 36% of owners say that the device is actually exceeded their expectations. They've saved more than they expected to with smart thermostats, which is a great sign overall for continued slow but steady uptake of this pretty critical home energy management device. Now, electric vehicles have a particularly interesting role as a change agent in the energy space. They're both an enormous source of new demand, and there are significant questions about the reality of the grid to handle projected EV growth. But also, EVs are essentially rolling batteries and potential sources of supply, which also forces totally new ways of working and planning infrastructure, planning for a grid that can handle bidirectional flows. Parks Associates data shows a general increase over the past decade in intentions to purchase electric vehicles. We saw a pretty enormous spike in 2021, some of that aligning with oil spikes and such, and interest has tempered a little bit as rising inflation constrains consumers' budgets generally, but there's no doubt that EV familiarity as well as EV interest is certainly growing domestically and far higher than it was just 5 or so years ago. At the same time, major auto manufacturers have committed to a conversion to fully electrified fleets across the next 10 years. The timelines may inevitably shift, and some brands will hit these milestones while others slip or pull back in different ways. But there are billions of dollars being committed to the funding of this transition to EVs, which is a substantial driver for this market. We ask consumers, Parks Associates surveys 8 to 10,000 US internet households every quarter, and we've certainly asked questions around electric vehicles to electric vehicle owners and intenders. We find that when we're talking to EV owners, our survey data finds that they charge their vehicles often. So about half, 49%, say that they're charging their vehicle daily, and they do charge at a variety of locations. However, nearly all EV owners, 90%, do charge at home. It's also the top location that those intending to purchase an EV report as their ideal charging location. It's their home. They want to be able to charge at home. And this charging load easily becomes one of the top power loads in the home, and clusters of homes together in a neighborhood or clusters of neighborhoods, adding charging at home has the potential to strain local capabilities and infrastructure. And so the growth in EV charging demands solutions that can help both consumers and utilities manage these new loads. This extends to the multifamily market as well, where demand from residents for EV charging support is growing. So Parks Associates surveyed multifamily owners and property managers in 2021 and found that property managers, 24% of property managers said that their residents are requesting EV chargers, and that rate doubles among Class A, which are essentially luxury properties. So the demand for EV actually exceeds the adoption of EVs today. People want to know that EV charging would be available to them even if they're not yet an EV owner. As resident demand increases, MDU owners and property managers show growing interest in acquiring EV chargers. So again, roughly 5% or so MDU residents have an EV today. 76% of multifamily owners and property managers said they're interested in acquiring chargers. Our team was at one of the leading operational technology conferences for multifamily properties last week called OpTech, run by the National Multifamily Housing Council. And EV charging was a very hot topic. Some properties are already experiencing issues around limited charger availability, also problems with people essentially siphoning electricity from unattended outlets. So properties are increasingly looking for solutions. One thing we heard is they're actually considering solving these issues with charging for a dedicated parking spot that comes with its own charger. So this lets properties earn back their investment in charging infrastructure, pay for electricity costs, while also preventing hoarding behavior among residents. We've also tested consumer familiarity and interest in advanced or sort of developing EV features that are just coming to market or being worked on today. Familiarity with these emerging concepts is still quite low, but once we explain it, consumers see the value. So, for instance, 51% of all US internet households that we surveyed say the ability to charge an EV while rates are low and then power the house with the EV battery when rates are high, 51% said that that's valuable. And this increases to 71% among those that are in the market for EV vehicles, right? For those who intend to purchase an EV in the next 6 months. Similarly, 50% of all households said that it would be valuable to use an EV battery to power their home during an outage. This jumps to 72% of those who are in the market for an EV. We'll be diving into both of these concepts in more detail, including what is actually necessary to make bi-directional charging at home, these use cases, a reality. We'll be discussing that a little bit more in our upcoming discussion panel. If you're interested in more insight on consumer habits and perspectives on energy consumption in the home, on solar, on electric vehicles, Parks Associates offers several recent studies, including home energy management and services in the home, electric vehicles and the smart home, and also this special study focusing on apartment residents and demand for smart apartments, including energy management and EV charging amenities. So with that, I'm so pleased to welcome Elizabeth Parks and our keynote grid point. Give us just a minute and we'll have that keynote come in.
Thanks for joining us today. I am Elizabeth Parks, the President and CMO of Parks Associates, and happy to welcome you to our sessions today. Jennifer shared some great data to set the stage for the next conversations, and I am so excited to welcome Greg Moorhead, the VP of Hardware Engineering at GridPoint, a leader in building technology to reduce the carbon footprint of commercial buildings and to update the electricity grid to be more efficient, reliable, and capable of integrating renewable energy sources. This is such an important topic. We're going to have Greg do a quick presentation for us. I've got a few questions at the end for him before we have our final session focused on the impact of EVs, moderated by Jennifer Kent. So Greg, thank you so much for joining us. I'll share more about what you are working on with GridPoint.
Thank you, Elizabeth. Hello, everybody, and welcome. I appreciate you joining today. As Elizabeth mentioned, I'm the VP of Hardware Engineering at GridPoint. I joined a few months ago, but before then, I've been working in the energy sector for 15 years, specifically in energy storage, developing flow batteries. In this role, I was not only involved in the development of the technology, I also interacted with customers regarding application and use cases for the battery storage and deployed systems. I worked with the DOE and the DoD and for multiple utility companies. So I think that that experience really set the stage for my time here at GridPoint, and I'm looking forward to the future here. Today, I'll be talking about distributed energy management with a grounded focus on commercial buildings and the potential for AI enhancements to reduce carbon footprint in the future. I'll start by reviewing the current state of energy consumptions and some of the challenges we face on the grid. I will briefly think critically about AI and big data and how that applies to energy management. I'll look at the importance of hardware and sensors and IoT devices in managing energy systems. Look at the whole building energy management platform, specifically what GridPoint is doing. That's the market segment that we're focused on. I will review challenges and opportunities in implementing AI-driven technologies, and then review the future of AI distributed energy management. Navigating cost and reliability for business, the transition to renewables and electrification are major factors impacting energy cost and reliability for businesses. The goals being set for decarbonization require not just enhanced production, but also reduction in energy usage. Preferably, this reduction can happen through optimization and efficiency. The deployment of renewables from both wind and solar and supply, wind and solar will increase supply, but at the cost of reliability. As we all know, the sun only shines during the day, if that, and the wind can be intermittent. These facts add strain to the grid when implemented. Trends towards electrification in manufacturing and, of course, the deployment of EVs is increasing the demand side, which on its own is creating rising prices for energy and increasing the carbon footprint. Extreme weather events and fluctuations in temperatures create additional stress on our existing energy infrastructure. Downtime, interruptions, and the unpredictable energy supply of renewables can also lead to significant loss for businesses. Additionally, companies are facing increasing pressures from consumers to adopt more sustainable practices. All of these factors are impacting the supply-demand balance. Ultimately, this impacts reliability and cost. This problem can be tackled in a myriad of ways. Supply can be augmented, but how can it be done without increasing carbon footprint? The trends towards solar and wind are helping the supply, but at the cost of reliability. Energy storage can solve some of the intermittency, but at the expense of, it is expensive and complex. Demand can be reduced, but at what cost? The best answer is efficiency and optimization. We really don't want to ask the users to reduce their production and reduce their life as it is today. There are many markets ripe for optimization, and much of the technology already exists. The question is how to package and deploy it effectively and economically. One of the answers are the management and optimization of buildings. Buildings are a key to the energy transition. There are currently 30 million commercial buildings under 200,000 square feet. 35% of the total electricity usage in the US comes from these buildings. Buildings generate nearly 40% of the global greenhouse gas emissions. So therefore, a sustainable future is not possible without optimization of the buildings. Heating, cooling, lighting, and refrigeration represent 66% total commercial building energy use. On average, 30% of the energy used in commercial buildings is wasted, according to the US EPA. All of these facts really open up the opportunity for buildings to be optimized and reduce the demand side of our grid problems. Can artificial intelligence help solve these growing supply and demand imbalances? Many people would say the obvious answer is yes, but deploying these technologies before they are ready could have a detrimental effect on adoption. Utility companies are deliberate in their deployment of new technologies, and AI will be no different. End users are finicky and want a guarantee that their data is safe, and it is imperative that customers are not negatively impacted by this technology. When I think critically about AI and energy management, I consider a bunch of essential questions to ponder. One, the reliability and predictability of the AI models. Utility companies want deterministic solutions. What is the methods for data collection and processing? How is that data managed and maintained and protected? What is the context and accuracy of the data which trains the AI models? As we know, AI models are trained from data, and if you don't have context, accurate data, it's very difficult for the models to have a positive impact. And of course, what's the ethical and privacy considerations as we move into this new world? A critical examination is key to making well-informed decisions regarding AI solutions and deployment. It is essential to explore the unique advantages AI offers over traditional predictive management models. We must assess whether the available data sets possess the context and the robustness required to support the necessary learning models. Negatively impacting either the end user or the utility companies by the deployment of AI could significantly slow their adoption. Big data serves as the foundational pillar of AI solutions. Deploying AI in energy management will require the collection and comprehension of extensive contextualized information from diverse sources such as sensors, meters, pricing models, and weather. It becomes paramount to gain insights into companies' data handling and processing practices, guaranteeing the precision and dependability of this data. AI can be difficult to control. It can be unpredictable if things are not correctly constrained. Customers, both end users and utilities, require deterministic and reliable energy systems. While AI has the greatest potential to optimize energy usage, the first order of energy optimization can likely be achieved through traditional control algorithms. Starting to optimize through traditional methods will enable the creation of accurate data, which will enable the training and more comprehensive AI solutions. Data algorithms can be used to predict energy consumption and patterns and analyze data to understand user behavior and preferences. This can enable customized automation and optimization of energy consumption. Effective deployment of these technologies will foster widespread adoption among consumers and business. Dependable and deterministic algorithms ensure transparency and trust in the AI systems. Well-accepted and understood algorithms will facilitate fairness, allow bias evaluation, and assess system performance. A thoughtful and informed approach is crucial as we embrace AI solutions in energy management, unlocking their full potential while addressing challenges and justifiable concerns. I can't understate the importance of sensors and IoT devices within the energy management sector. Contextualized device control requires multitudes of sensors. Multi-sensor devices integrate different types of telemetry such as temperature, motion, light, and humidity. These devices can reduce deployment costs and support a holistic view of energy management. By aggregating the data from these sensors, facilities can view an encompassing perspective on energy usage, environmental conditions, and system performance to help identify patterns and optimize energy consumption. This will enable benefits such as cost reduction. Cost reduction can be achieved through improved lighting and HVAC controls. For example, simply making sure the lights are off at night through scheduling or utilizing ambient light monitoring can reduce lighting costs. HVAC comfort control settings can be modified based on occupancy, weather, and scheduling, which will significantly optimize energy usage. Maintenance tasks can be triggered based on monitoring efficiency profiles or energy usage trends. Active real-time monitoring allowing improved maintenance scheduling and optimum operational efficiency. Decision-making can be improved through with optimization and comprehensive telemetry. When to start heating or cooling can be determined based on weather forecasting or pricing models. Efficiency can be improved simply by not running systems when not needed, while simultaneously monitoring the efficiency of the building and its systems while under operation. Without comprehensive telemetry, none of this can happen, neither through traditional control algorithms or through enhanced AI models. Obviously, you need more than just hardware in order to run an energy management system. You have to have software, and these two things will work hand in glove together. It's critical to pair hardware with energy management software. Together, they provide a real-time data, enhanced accuracy, comprehensive monitoring, predictive analytics, and enable remote facility management. The combination of software and hardware enables businesses to create accurate digital twins of building assets for energy management. This all enables benefits such as energy optimization, which can be achieved by software implementing standard control solutions or potentially AI models in the future. Predictive maintenance, such as utilizing digital twins to proactively warn the user of pending failures so that they can be addressed before an event such as refrigeration failures could cause the loss of thousands of dollars of inventory. Real-time demand response, which is the holy grail in commercial building management. This can only be enabled through software aggregating large numbers of buildings with the ability to effectively control the usage of energy within these buildings. Ultimately, all of this results in increased cost savings and hopefully reducing carbon footprint as the ultimate goal. But businesses will only choose to use the technology if the bottom line is positively impacted. As discussed, buildings are a significant part of the grid's energy load. Optimizing buildings will have a significant impact on the demand side of the energy reliability problem, and this is the primary market which GridPoint is active in today. The whole building approach focuses on the building as an integrated entity rather than looking at isolated systems. It ensures that all aspects of the site are efficiently using energies from the structure to the energy-consuming devices. A comprehensive model of a building is required to improve energy efficiency and sustainability across an entire facility or even a group of facilities. Even the simplest business has a substantial amount of systems to be monitored, such as HVAC, lighting, main power load, and submeters. And then as the future unfolds, even EV charging. There are many other small businesses which have a larger footprint of hardware that needs to be monitored, such as pharmacies and others where you need to watch refrigeration to make sure that the systems don't have failures there in order to which product could be affected. So there's many details that can be handled by more hardware or less hardware, and it takes a comprehensive software suite in order to manage that effectively. Energy management systems require smarter buildings. Today, we look at a building as a functional entity. The utility bills it individually. We optimize cost at the building level. To enable grid resiliency, we must look at a fleet of buildings as an aggregated unit. This will be done through smart buildings being integrated through an energy management system, allowing customers and utilities to manage them as a fleet. The fleet management will create stronger grids. GridPoint Intelligent Systems drives continuous efficiency and enables businesses to unlock new renewable streams for playing an active role in the grid stability. It delivers energy intelligence, efficiency, and immediate savings by controlling and optimizing common energy consuming assets inside of a building, such as heating, cooling, lighting, and refrigeration. It enables the integration and control of distributed energy resources, such as battery storage and EV charging, in a cost-effective way through a single platform. It empowers the monetization of distributed energy resources through grid interactivity. Grid's intelligent energy network enables a more dynamic way of balancing energy demand and supply in real time with precision. It unlocks access to the untapped capacity across the commercial sector. It provides a decentralized network of aggregated capacity that provides energy markets the ability to leverage buildings as a reliable and grid resource whenever, wherever possible. The ultimate goal is transforming a fleet of buildings into a virtual power plant. This is being done through hardware-enabled software as a services, or SaaS, producing a real-time optimization and control of the building assets. The virtual power plant can harness decentralized energy, such as solar, battery power, and flexible demand, allowing energy optimization at the grid level. This solution will enhance the resilience and sustainability of the grid, providing a more reliable and resilient grid while simultaneously reducing a building's cost and carbon emissions, ultimately producing reduced energy costs and potential revenue streams through demand response interactions with the grid. There's a myriad of challenges to be dealt with when we think about AI-driven energy management systems. First is privacy and security. Effective AI solutions require access to a significant amount of data to function effectively. This can be resolved by implementing stringent data encryption and anonymizing techniques to safeguard user information. We must establish clear privacy policies and security around the data. Setup costs. High setup costs can be substantial, deterring small entities or budget-constrained organizations from adoption. This should be resolved by creating cost-optimized designs and leveraging economies of scales, such as that seen in the IoT ecosystem. We can also utilize utility and/or government incentives to help ease the financial burden of deployment. And the foundational problem is the accuracy of the data. Technical issues and glitches can lead to inaccurate data analysis, hindering optimal energy management. We must perform rigorous testing and validation of AI algorithms, implement regular updates, and a robust maintenance and support system to mitigate our concerns. We must employ redundancy and fail-safe modes to ensure continuity when discrepancies occur. There are a myriad of opportunities for using AI in energy management system. Enhanced user control. We must first think of the user and must focus on comfort and functionality and ultimately trust. Energy forecasting. If you can't accurately forecast, it will not be possible to create control algorithms which positively impact them whether they are driven by AI or standard modeling. Predictive maintenance. Probably the lowest hanging fruit is the predictive maintenance and monitoring. There is little risk because these usually require human verification, but huge payback. If you can catch a refrigeration failure or an HVAC failure before it happens, you can reduce energy costs and potentially save thousands of dollars in inventory. Grid optimization is ultimately a combination of accurate data and control options. Utilities are slow to move and risk averse, but the potential benefits will eventually be required in order to meet our optimization goals. Demand response is ultimately about giving utility grids more options to manage the demand side of the problem through grid disturbances. A primary roadblock is orchestration of disparate, essentially autonomous utility customers from residential through medium to small business to large users. GridPoint is actively building energy management system infrastructure to service a slice of the market. Renewables are the adoption of supply options, with a low carbon footprint. However, these intermittent producers cause additional grid management problems. Ultimately, this is all to reduce carbon footprint of energy production and consumption. And it will require, the first level of this can be achieved with standard algorithms, but AI will be required to meet the optimum goals required. Traditional centralized power generation will be complemented and in some instances replaced by distributed energy resources. AI will optimize the coordination and the utilization of these distributed assets to make the grid more resilient. GridPoint products provide the capability for the utility to monitor, aggregate, and modify energy usage at the granularity of a building or a set of buildings. AI solutions can self-heal from faults, autonomously reroute power during outages, and optimally distribute energy among different sources and concerns and customers. These types of supply AI automation will need to be implemented by utility companies. Proactive and real-time demand response. The evolution of AI will enable real-time, proactive demand response, predicting energy demand spikes before they occur and adjusting demand accordingly, leading to peak shaving and load smoothing to reduce strain on the grid. Integration of distributed energy resources. Optimization and integration of various distributed energy resources like solar, wind, and energy storage systems will be able to manage these resources in real time, ensuring that excess energy is efficiently stored and discharged when needed to ensure the optimal energy production and consumption. And that's what I have today, and thank you for joining. If there are any questions, this would be the time. Thank you.
Hey, Greg, thank you so much for all that great information. That was really amazing to listen to. You know, the impact of artificial intelligence is, it is going to be huge, and you certainly exemplified that, sharing some of these details of what you're working on. I think we have time for just maybe one or two questions. We're very focused in on the consumer and what the consumer is going to be able to do in terms of their role in the energy landscape at home. And so could you maybe explain a little bit about this idea of energy prosumers and what their role is, and then that impact of these applications stemming from artificial intelligence?
Well, as consumers or prosumers, people looking to buy this technology, consider implementation and adoption of it. It's critical that the applications listen to the consumer, their desires, and optimize for their comfort and their cost efficiency. So a combination of software and hardware are going to be required to do that. And really the key to adoption is going to be to simplify that and then have a very reliable and deterministic user experience as they interact with these systems, whether they be that in a building like I'm discussing, or whether you're doing that at home. The problem of how you encapsulate all that and get that value to the grid is where, that's where the big wins are going to happen as we do that work. And that's where AI and big data can really come in and optimize that in a way that, humans can't.
And so do you see that management of energy consumption, and we could talk about in the home, or let's maybe focus in on the home environment. Is that going to be built off the analytics and that control point that consumers have, just being able to understand consumption to begin with? And what do you think might be the most impactful way that consumers end up really being involved in all of this?
All these are a little bit, it comes down to the individual user and the way they want to interact with it. It's critical that we consider the comfort levels of the user and the simplicity of a application. The bar is set pretty high with the internet and the Internet of Things for how users interact with a device or with a solution. And as we move forward in time, it's going to be critical that we give the user the results they desire without compromising them and still be giving them the efficiency and energy improvements that they're expecting.
Okay, great. And what about this idea of distributed energy management systems, helping us transition into this new world of sustainability and resilience? Can you maybe expand a little bit on that?
Yeah, I mean, it's going to be difficult as the grid gets more complex and we distribute energy across a lot more sectors or a lot more devices, whether it be solar, wind, storage. It's going to be critical to have software as a service type centralized systems that's monitoring and managing that. And those problems quickly get out of the hands of standard algorithms. I think, in my view, it's going to be over the next few years, you're going to see a lot of deployments of relatively simplistic algorithms that may get you 50, 75% of the cost efficiency that you're looking for. But in order to get to that 95% of what you could conceive of, you're going to need those artificial intelligence features, big model data that can actually understand user preferences and how those work with efficiency needs. And then also, as you have events where the grid needs to reduce demand, how do you do that without negatively impacting the user is going to be one of the trickier parts. Certainly battery storage can augment and start to improve that problem significantly. Who manages the battery storage? As you talked about earlier, we talked about EVs. Can EVs be part of that equation? Can they actually be part of the grid? That also needs to take into account the user's plans for the day. The last thing you want to do is discharge your car just before you go on a trip. So these things are complex, and tracking data and people's preferences and normal usages is where big data and AI can come in and solve that problem.
Okay, great. And final question, we're almost out of time, but do you have any suggestions on what organizations should be doing at this point? Of course, there's a lot of types of companies in play here, so whatever you'd like to speak to as far as leveraging these new technologies that are coming into play. So any advice for the companies out there who are working in these areas?
Certainly as a customer or consumer, you really want to look for people like GridPoint or others to provide you with a solution. It's very complex to answer these problems, and you need economies of scales required to make the economics work. Companies that are such as GridPoint need to consider carefully how they deploy hardware, how they manage data, how they aggregate that data, both for reliability of the information. If you have garbage data sets, then you're going to have garbage solutions come into play. So you need to make sure the data is accurate and secure. So it's a combination of looking at the legacy and making sure you can maintain your current state of affairs while trying to create the data set that can enable AI in the future.
Well, great response there, Greg. We greatly appreciate your time. We know it's very valuable. We think you've given a lot of information for our audience to digest. And so thank you for being here, and hopefully we'll see you in person soon.
Thank you, Elizabeth.
Okay, well, we are going to be moving on here to our next session focused on electric vehicles, and Jennifer Kent, our VP of Research, will be joining us here in just a second, along with our amazing panelists. So we'll be right back, and thank you again for joining us today.
Great. Thank you, Elizabeth and Greg, for that great presentation. As Elizabeth mentioned, this panel discussion is focused on electric vehicles, energy, and energy management. Are they a threat in the sense of the consumption and the load they're adding to the grid, or potentially an asset? And both. So very excited to be discussing with our panel. Again, I'm Jennifer Kent, Vice President of Research with Parks Associates. So as we get this panel started, I'm going to ask each of our panelists to introduce themselves to you and introduce their organizations before we dive into our conversation. Also, for our live audience today, you do have the opportunity to ask questions to the panelists. So there is a questions and a chat tab in your swap card platform, so you can put any questions that you might have for the panelists in there. There are also some polling questions, and I'll be calling on those polling questions later to see what the results are. So please, if you haven't already, go ahead and take those polls, and we're looking forward to seeing your insight. So with that, I'd love to introduce our panelists, and I'd love to start with Alex, who is the founder and CEO of Lumen. Hi, Alex. Thanks for being here today.
Yes, hi. Thanks for having me. Hello, everybody. It is a pleasure to be here with you today. My name is Alex Bajanov. I'm the founder and COO and president of Lumen. We develop a home load management system, also known as a smart panel. And we work in the markets like solar and energy storage, where we pair our products with solar systems. We work in grid services, delivering demand response and other grid services through our product to utilities and demand aggregators. And we work in the exciting field of electrification, allowing people to bypass the additional upgrades to their home infrastructure when they electrify their homes and add EV chargers, and then delivering value to the grid by helping them to avoid additional investments into the distribution infrastructure.
Thanks so much for joining us today. We also have Sarah Delisle, who's the VP of Government Affairs and Communications with Swell Energy. Hi, Sarah. Thanks for being here.
Hi, a pleasure to be with you all today. As mentioned, my name is Sarah Delisle, and I am Swell's Vice President of Government Affairs and Communications. For folks not familiar with Swell Energy, we are a renewable energy and smart grid solutions provider that's dedicated to uniting property owners, businesses, industry partners, and utilities behind the shared goal of reliable, cost-effective, clean, and flexible energy. Swell Energy is both a renewable energy project developer, a financier, as well as a grid services provider, bringing simple and secure energy solutions and sophisticated grid service programs that are customizable to meet the diverse needs of all of our stakeholders. To date, Swell has 600 megawatt hours of virtual power plant contracts with utilities across the United States, and we're actively bringing online 26,000 energy storage devices to fulfill those contracts in various markets.
Fantastic. Very pleased to have your perspective and your voice in the panel today, so thanks for being here. And next we have Sean Steele, who's the Sales Director for Zeal Energy. Hi, Sean.
Hey guys, how are you doing today? Really happy to be here. So like Jennifer had mentioned, I am the Territory Director here at Zeal, and Zeal is a level 2 EV charging company. We have a patent around a technology that allows us to be 100% reliable from a connectivity standpoint, and looking forward to discussing on this panel today.
All right, great. Excited to hear more about that proprietary technology and what that reliability means. I'm sure we'll get into that. Also, we have Cedric Tai, who's the Director of Strategic Initiatives with Switch Energy. Hi, Cedric.
Hi, folks. Good afternoon. Happy to be here. My name is Cedric Tai. I'm the Director of Strategic Initiatives with Switch Energy, and that's a switch without the I. The joke is we at Switch, there is no I in team. We believe in partnerships and collaboration across industry. And we are a charge point operator, a network company. We are software first, and in our entity, in our identity, And we basically just want to simplify, make EV charging accessible, equitable to people that are living in buildings. So these are multifamily, retail, commercial customers. And we just want to make sure that there's a way to charge their cars and make it as seamless as possible. Yeah, looking forward to chatting more on this panel.
Great, fantastic. Thank you, Cedric. No iron switch, love that. Okay, and next up we have John Romero, who's the VP of Industry Solutions at Landis & Gyr. John, thanks so much for being here.
Well, thank you for having me. It's a pleasure to be here. As you said, I am John Romero. I'm the Vice President of Electric Vehicle Solutions at Landis & Gyr. And if you're not familiar with Landis & Gyr, we're mostly well known in the metering side of the business. We've been in business for more than 125 years. And so you could say we are pioneers in the metering space. And moving on from that, we went to smart meters and AMI. And now we've introduced a new metering technology for the grid edge that we believe will help us solve the problems that we're going to be talking about today. And we've moved into the EV space because EVs will be one of the largest, if not the largest, load inside a home. And so our mission is to help the world manage energy better. And we feel that this is exactly the space that we want to be in with level 2 chargers, charge point operation software, and e-mobility software.
Well, great. As we bring everybody back in here for the conversation, John, I'd love to start with you because I want to talk about, I sort of teed up about how when we think about electric vehicles and their role in the larger energy ecosystem, right, they have this kind of, two-sided impact in the sense that there's a big projection for demand on the grid, but also potential resource. And so I want to start with that first element. And if you could talk a little bit about how you see EVs impacting the grid from a consumption standpoint, and also homeowners. So I'd love to start with John there and then go to Alex.
Sure, I can give you a little bit of perspective from what we're looking at. From our research, what we've seen is that there's going to be somewhere between 25 and 30 million EVs in the U.S. by the year 2030. We're sitting somewhere around 3 million EVs today. So we're just at the point of that hockey stick where we're starting to see a tremendous amount of growth. And that growth is going to result, of course, in a lot of electric demand on the grid. And so utilities are going to be preparing for how to address that. And since we also know that about 80% of charging happens at home, we'll need to have technology in place that allows a greater consumer engagement and how charging occurs and when it occurs. So we don't want customers charging at the peak hour, right? We think that could create challenges with transformer overloads and potentially the need for additional capacity resources. And so what we want to do is not impact the grid in that way because that just adds to the cost of the grid and then eventually cost to consumers. So we feel that providing technology that's going to allow consumers at the grid edge to make some decisions, to be able to shift their load, and to be able to charge at the least cost time is going to be really important for everyone involved, not just the utility, but also the consumer. And, there's a lot of discussion about whether the grid can handle it. And, my personal opinion is yes. If we charge smart and we create the right incentives with consumers and we provide the right tools, there is capacity available on our infrastructure, but that means we shouldn't have people charging, between 3 and 5 o'clock in the afternoon, for example. We're going to have to find ways to incentivize customers to charge during those off-peak hours, but still allow the consumer to have a full charge on their vehicle and disrupt them very little as we start to progress into this new space for us.
Absolutely. Alex, what are your thoughts there?
Yes, John mentioned, and I completely agree with him, that EVs are coming, and they're coming very fast. And an EV charger, level 2 EV charger, is going to be the largest load in pretty much every single home. Unfortunately, from what we see, and that's where I a little bit disagree with John, we don't have the grid ready for this. Yes, there is capacity. We can generate that additional electricity. However, the mass adoption of charging at home will put enormous stress on homes' infrastructures. So essentially, in order to put a level 2 EV charger, you need to spend, as a homeowner, $10,000+ to upgrade your circuit breaker panel and then upgrade your utility service to a higher amperage in order to enable that kind of bandwidth in amps. to charge your car. But then, because the grid is built bottoms up, the utility will have to go and upgrade the transformer on the light pole next to your home. And then when they upgrade a couple of transformers in your neighborhood, it will be a larger transformer upstream and all the way to the substation. And we're talking about billions of dollars that have to be invested over the next 5 to 10 years. And if anything, we know, right, it took us over 100 years to build the grid as it is, and it's a marvel of engineering. But we don't have another 100 years to essentially double its throughput capacity. And that's paired with the challenges that homeowners will have adopting EV charging at homes. That's where, in my opinion, the real trick is, how do we ensure that that's possible without dramatic and rapid investments into the grid and into our homes?
So is there a particular role you see for the panels, right? To play in the middle of this, right? From where the
absolutely. I think there's a lot of place for different technologies. Naturally, as someone who founded a smart panel company, I'm very biased towards smart panels, but I can see how various appliances, the EV charger itself, for example, will work with kind of in the orchestration of loads inside your home. Because EV charger on its own, well, it only knows what the EV is doing, right? It doesn't know what the home is doing. It doesn't know that you're doing laundry or that it's really hot and the AC is cranking up. Like, you need to have that holistic picture of what's going on in the entire home and manage all these loads in concert. So absolutely, I'm sure smart panels will have a great place in this, but also will other devices.
Okay. Now, Cedric, I know that you have had a long history at utilities, and then also now at your role at Switch. I'd love if you want to add some commentary, and then maybe talk about the particularities of the multifamily market and what the impact will be on multifamily properties from the coming EV swell.
Yeah, sounds good. I was just out of a conference here in Charlotte, North Carolina, and talking with Duke Energy, and then they were saying how right now the customer experience is kind of scary. If you bring an EV over and someone buys an EV and say, hey utility, just to let you know, I put an EV charger in my house. The utility goes, wait, hold on a minute. If you do this and then your neighbor do this, wait a minute, my transformer is going to be oversized, and by the way, here's the bill. You're going to have to pay for it. So the customer experience is quite a struggle for utilities when it comes to the overloading of their infrastructure. So there's got to be a way where on the building level, at the home level, there's ways to say, well, given the investment and the cost of infrastructure on the grid side, there's ways we can control it, limit the energy, or spread it out such that the cost for infrastructure upgrade is minimized. So that segues into the multifamily, where we're actually seeing building owners and property managers coming to us and say, hey, we've got a 15-year-old building and there's no heat pumps, and climate change is happening. People are complaining about the heat, and we need to fix it. And at the same time, there are EV owners asking for charging infrastructure in a very already congested underground parking lot, or just generally parking lots. So that's the kind of struggle that these building owners are facing, and we need to have a solution for that. And then us on the Switch side, that's exactly the problem we're trying to solve, is to say, well, you don't have to make that choice between heat pumps and EVs. There's a way to control it and manage them such that we can all play along. There are sharing components. There are ways to change our user behavior such that the charging is equitable. And so that's exactly the challenge we have ahead of us, and we have to solve that together.
Yeah, just on the great point that you were making about utilities not really being ready necessarily for a whole neighborhood to go electric in their transportation. How about utilities being ready for whole multifamily sites to really ramp up their charging infrastructure? Are there things that you're seeing in multifamily where the properties are working with local utilities, or utilities ready for what's happening on the multifamily side? Cedric, back to you, and then maybe.
Oh, sorry.
Yeah.
Oh, sorry. The question was So do you mind repeating that again?
Yeah, just whether or not the utilities are also focused on how there might be a spike in demand in little specific localities related to multifamily properties, scaling up their electric charging infrastructure on their properties, and whether or not that same issue exists.
Yes, exactly. So the multifamily side, the transformer is bigger, but they do have a service transformer that's spec'd in at the time of construction, and so that has limited capacity, and the upgrade of that is even higher. And building owners are basically competing between like a roof upgrade or changing the landscaping and electric vehicles. So the budgeting for that is some of the biggest challenge that we're facing in this space.
Yeah. Sean, over to you also in the multifamily space, right? What are you seeing as far as how properties are looking to think about this, coming demand for electric vehicles and managing those, budgeting is a great point, budgeting for these upgrades that they might have to make.
Yeah, no, in multifamily, it's a wild time right now. I always hear like, hey, EV is coming. The reality, like EV is here. Like we are on a hockey stick trajectory, but EV charging in the multifamily is needed today because to John's point, it's like the demand for it, everybody charges their electric vehicle like you and I charge our phone. And I don't know about you, but I charge my phone before I go to bed. So in terms of the restrictions on the actual utility, they're charging their vehicles at off-peak times, which is great. But the demand is so high right now that working with not only the utilities, but the multifamily companies to understand like, hey, get somebody on site. Let's see what you have from available capacity. And then talk through different strategies of, okay, hey, with what you have available, here's how many chargers we can put in. And then going through different options from panel upgrades. But we're starting to see more and more of it. Like 2 years ago, people were putting in maybe 1-2 chargers. We're seeing a lot of the new developments putting in 20. We put in 40 at an Austin property. So the demand is definitely getting higher on the multifamily side.
Are you seeing more properties starting to look at EV charging more as, as a differentiator from other properties that might be out there and attracting residents to their property? Or are we already at the point where it's kind of table stakes and resident demands there, so you have to put it in regardless?
Yeah, it's, whether it's a retrofit or whether it's a new build, I always say EV charging, it's not an amenity. It's absolutely a necessity. If there's not an EV charger at the property and your resident purchases one in the middle of that lease, if there's not adequate charging locations at the property, they're going to look at a property that has that. So definitely a huge differentiator for the multifamily space. But again, not really an amenity. It's a necessity for these drivers.
So Sarah, I want to bring you into the conversation. If you have any comments to share about the, coming, of course, demand and challenge of EVs on the network, but then also, what's the opportunity here to be able to leverage EVs as a resource if done in a coordinated and intelligent fashion?
Sure. So this is a huge, tremendous opportunity, and virtual power plants are going to play a very, very important role in order to marry our generation capabilities with our demand and our load needs. And this transition is unlikely to be smooth because in the greater context, while we are bringing EVs online rapidly, as the other panelists have mentioned, we're also retiring our fossil-based generation. We're retiring up to 180 gigawatts of power by 2030. And we're bringing on a lot of intermittent renewables in the meantime, leading to a 200 gigawatt capacity gap. And so really looking to what are the resources out there that can help us meet those capacity needs on the grid. Certainly EVs play a very, very important role. And we also see the desire for people to be doing a whole home backup with their EV. Currently, the Tesla Powerwall is a very attractive product on the market, and many battery manufacturers that we work with are coming into that space to fulfill an important need because weather-related outages across the United States are also driving greater demand for batteries in homes. And a lot of folks are looking to EVs to kind of meet that need in the future, where they can interconnect their car to their home and back it up that way. But again, a lot of challenges exist on the grid in order to be able to achieve that. So where Swell is focused, and we were really excited to put out a press release this past week, we have had our own DERMS, Distributed Energy Resource Management System, in place for several years now, really focused on the optimization of solar paired with home batteries. This collaboration with Shifted enables us to integrate their distributed energy resource management system that is much more focused on those smart appliances and load needs at the home, to include EVs. And so with that integration, we're really optimistic about our ability to do that whole home energy integration and optimization, whereby we're leveraging time of use tariffs to both make energy more affordable for homeowners, while at the same time benefiting the grid, and working closely with utilities to identify what are those specific grid service needs in any particular circuit, whether it's fast frequency response or a non-wires alternative, capacity build, capacity reduce scenarios. We're in various contracts doing all of those grid services. And it's a very exciting time because the capabilities of EVs to just provide the capacity alone is extremely valuable to the utilities, as well as looking forward to what the advancements in the technologies will be to provide different types of grid services in the future. Once the integration of homes with cars happens for backup, it opens up a litany of new opportunities that we're very excited about.
So maybe I can follow up with you here, and then I might go back to Alex on this question. But so when you think about the coordination of EVs with the home and with the grid, there's different levers that you can pull. So you mentioned, time of use rates as one way is to encourage certain behavior among EV owners. Then there's actually coordinating the load in the home and maybe giving the consumer, some control over when certain loads are happening, or automating that. And then there's actual calls on the resource in a demand response event, and coordinating that type of behavior, in a particular peak event where you need to shave off load and coordinate that and call on that asset. So maybe can you speak at all to, of these different levers, right? What you see as either most impactful or maybe most near term, and even maybe already showing some fruit.
Sure. So I guess the word that first comes to mind is truly optimization, right? The software capabilities to not just look at the tariff that's going to drive certain use patterns within the home, but also looking at individual consumption patterns. That's also looking at the forecast and weather, and taking all of that data to determine which loads are best performed at what time of the day. And increasingly, it's not only time of use, but in places like California, where I live, right, there's slice of day reform that is further divvying up those pricing categories by hour and by month. And there's also discussions about real-time pricing. And so in a very dynamic, price signal driven environment, these software capabilities become extremely important for really optimizing the load within the home and providing maximum benefits both to the end consumer as well as the utility and the grid. I would say right now, to your last question, which elements are perhaps driving, was it the most value, Jennifer, you were asking about, or the?
I was kind of saying more near term, are already starting to maybe show fruit in reality, but
I would say like those varying dynamics are active in many of our grid services programs today. So those activities are happening now, and in varying degrees depending upon what the grid services needs are for the respective utilities. I would say one element that I'm very excited about as far as the deployment of EVs and the deployment of more clean renewables that are also intermittent is this need to optimize, right? One benefits the other. So where you can, or potentially harms the other, right? So in situations where a car battery can soak excess generation on the grid where it might otherwise be curtailed, you also have the risk of that car charging, potentially overwhelming the grid and causing rolling blackouts. So it's really like a very critical need for us to be able to align both generation and load.
Well, so Alex, I mentioned going back to you there again, sitting as kind of the panel and seeing the different loads within the home. Can you talk about any insight that you have on that, the opportunity with coordination and some automation to leverage the EV as a part of the solution? And then we're going to go to our first polling question. So if you haven't gotten in your polling answers, please do.
Yeah, thank you. And yes, absolutely. Because we at Lumen, we have access to this data on various loads in your home and the ability to control them individually or in concert with each other. We really believe in the fact that the homeowner, in many, many ways, can live their life without major interruptions. And I know that, for example, demand response is something about clipping the peak, right? You want to reduce that. Well, our mindset is that it's not about clipping the peak. It's about undermining the peak. So, for example, you maybe can still charge your EV if you really need so, even during high peak hours, but at the same time, maybe the system automatically can shed your other loads. Maybe it's a pool pump, maybe it's a water heater, maybe it's something else. And for that reason, a homeowner can be really in control of their life in what are they doing without really having grid or utility in kind of pushing that onto them. And then, of course, as Sarah mentioned, there's a great value in EVs kind of charging or absorbing that excess capacity. And of course, there's a lot of discussions in our industry about this exciting technology, which is bidirectional charging. Unfortunately, some of the challenges we're seeing is that bidirectional charging is still a little bit far away from where we all are today. Yes, there is, if I remember correctly, there's only one EV with that capability, which is Ford F-150 Lightning. But it requires enormous efforts on the homeowner side to be capable to unlock that bidirectional charging and bring that value in like additional equipment that has to be installed and so on. And I think that we need to strive to deliver value to homeowners where it's all seamless, right? You just plug in your EV charger as you always do, and it works. Unfortunately, that's not the case today.
Right. Well, so that's a perfect segue because our first polling question actually is about challenges to bidirectional charge. So we asked the attendees who are live with us today, what will be the most potent challenge to bidirectional charging? And we actually got a pretty solid spread. So not one straw. Everybody thinks it's going to be the same challenge. So the number one answer, about a third of people said home infrastructure limitations. Our homes are not ready for this. And then tied in the number two place, battery degradation concerns, right? And grid infrastructure limitations. And a few people said lack of consumer interest or regulatory barriers. So I'd love to come to John and then Cedric on your thoughts on, the challenges of integrating EVs, more widely into the ecosystem, and particularly bidirectional charging, the challenges that we need to overcome to make this a reality.
Yeah, I really think the question there is, the need and the desire for bidirectional charging. I think that, there's multiple stages of what we're going to be going through here as we see the EVs take into effect into our environment, right? We're first going to see the ability to drop them off as basically the demand response. That's the easy piece. We've done that for many, many years, but as we progress and, Ford Lightning was mentioned, I think that's probably the next evolution of where we want to go. And that is, an incentive the utility is probably going to have to provide also, in that it's worth some money to the utility for us to drop off, right? So the first one is easy. There should be some incentive to curtail some load. The second piece is you're basically creating a microgrid with your home. And that is something that right now does take a tremendous amount of effort. It's $8,000 to $10,000 modification unless you know how to do it yourself, right? And create a sub panel and do things inside your home to have that bi-directional piece. But pushing that onto the grid, I think, is a whole different topic. I think if I were to have, an electric vehicle, the utility would probably have to pay me quite a bit of money that I would be wanting to push my electricity from my battery on my car into the grid, or the degradation of the battery. There's a lot of other issues that would need to be involved there. Now, that's speaking from what battery technology looks like today. In the future, it could be very, very different, and we may not have to worry about the degradation, but I think this is going to come in phases. The first one being just very typical demand response type of things. The second is going to be how we manage that maybe in a microgrid, and then that last phase is going to be how we push it out onto the grid. But I don't see that happening in the near term. I see that more of a long-term solution as the batteries technology gets better, and you're not worried about degradation as much.
A great comment. Cedric, from you, what do you think are going to be the top challenges here?
Just adding on to that, the one thing that I'd like to add is the vehicle to grid standardization. So that's a policy thing on the charger itself, on the port. And so, there's groups like EPRI who have a dedicated vehicle to grid forum and a working group that's working through that. But the challenge is it's quite large, and there are parties that are waiting for the standard to come out. There are parties that are like, oh, we're just going to go ahead and do this. And so it's a bit of a mess right now in terms of defining that. And so OEMs are struggling to figure out what to do in terms of investing in vehicle to grid technology. And then, as previously mentioned, just the cars themselves and the battery degradation risks that needs to be quantified. In terms of the other question on innovation, right? Or what we can do to make things a little easier. There's definitely a lot of work, and we're trying to look at that on are there better integrations through APIs and companies coming together to say less handshake and create visibility for each other. So the grid utility side are asking charger companies to provide data to in a, for now, off real time, but in the future more real time basis, such that they can improve their visibility into the system and then improve their long term planning. And then on the demand response type market participation, there's work in certain jurisdictions. I would say, namely California, New York, Connecticut, who are driving a lot on empowering EVs to be a demand, and so adding to the VPP conversation. Those are great opportunities in markets where parties, utilities, software companies, and hardware companies are coming together to do more integration and partnerships. So we're seeing good progress and lots of discussions. It's an exciting space to be.
Yeah, that's fantastic. I'm glad that you mentioned that, kind of the partnerships and the integrations, and also some of the regulatory barriers and changes. Because one thing I did want to talk about, and maybe Sarah, back to you here, especially with your role, with government affairs, if you wanted to comment on any particular regulatory barriers or changes that are coming. We actually did have a question that has already come in as well around funding for infrastructure changes. So we have seen funding, coming out of the Biden administration for infrastructure changes and rebates to make upgrades at home. But I don't know that that's nearly sufficient for what we need for something like bidirectional charging. Is there anything that you can comment on the regulatory side of what's happening and what's kind of needed in a big way?
Yeah, you pointed directly to the greatest momentum coming out of the policy landscape, which is the IRA and the IIJA funding, I think, for new technologies, the amount of grants that are now available for all sorts of battery technologies are nothing like the industry has ever seen before. So there's a lot of money on the table right now to do more R&D as it relates to advancing the technologies. Related to transmission and distribution, I've heard figures from the administration as high as $3 trillion are needed to build out the infrastructure required to bring all of the new renewable energy to market, as well as meet the new demands on the grid. But I've also seen some really interesting reporting come out about the role for virtual power plants and non-wire solutions that can bring, by really smartly managing a lot of our distributed energy resources where they're located, can bring down those infrastructure costs considerably. So they may not be as large and as scary as we think they might be. I think what I've also heard from government officials is that while the infrastructure cost may be in the trillions of dollars, right, not all of that money is going to come from the government. It's going to need to come from industry. And so how do we create the market dynamics such that that industry is helping pay for a lot of these system upgrades? So certainly a lot of work to be done in the policy landscape. I think where a lot of my focus is at the state level, really trying to work on establishing new goals for virtual power plants in the, at the gigawatt level, and create some traction with policymakers that way. But also working on, there's a lot of limitations for how virtual power plants can operate in the market today based on your technology and how you can stack those resources. And so to the extent that we're curtailing some of these technologies, and I'm not even thinking about EVs when I say this, it's like your smart thermostat with your solar, with your electric hot water heater, and perhaps your EV, there might be a variety of different programs that you're eligible for to participate in with each one of those technologies, but the market won't let you participate in multiple at the same time. So really trying to create these pathways that afford for this whole home integration to be able to be recognized and valued appropriately for the services that they give back to the grid.
Yeah, fantastic comments. Thank you. We do also have a question that came in related to multifamily specifically. So, Sean, I might pitch this to you first, and Cedric, if you want to weigh in, or anybody also. The question is around, what incentives are in place for MDU residents to participate in bi-directional charging initiatives. Is there a reason that MDU residents would want to participate? Or if you want to comment also on why should MDU property owners care, about this as well. Sarah made a great point that all the funding and infrastructure build out isn't just going to come from, government funding. We've already talked about multifamily properties maybe sitting in their interests, to get charging on site. So any comments that you have there?
Yeah, I think from a interest level from, multifamily residents, I don't know if that's there at present, right? I think incentives would be a great idea for it. I'm starting to hear more and more from the multifamily developers, the multifamily owners. Again, I think the technology and the infrastructure were a few years out, not only on the property level, but on the vehicle level and the charging level. But in terms of actually getting the residents on a multifamily to do it, I think there needs to be some groundwork done. I think there needs to be some incentives in place for them to want to do that, because again, battery degradation and making sure that their vehicle health stays in check. So I think there's some improvement that can be made there, but I definitely think it's something that we're going to start seeing more and more on in the multi-tenant scape.
Yeah, it's certainly unlikely that they'd be able to directly power their unit in an outage, right? As far as, that type of thing, will they see the dollars and cents from participating in some sort of sell back to the grid? Cedric, any comments there?
Yeah, it's just, you live up at whatever 20th floor, and then your car is at the basement. And how do you make sure the electrons have no eyes, right? How do you make sure it goes back to your house? So that's the kind of the difficulty there. Vehicle to grid side, we did a project in Ontario where we did a pilot and put it in a parking multi-res context, and demonstrated the technology works, but it's with a Nissan Leaf, and so echoing just the previous comments, the car manufacturers do need some work to do on top of the standards and policies that we mentioned before. In terms of incentives, what we see for now is they're stepping stones, right? Like, first of all, just having cars, EVs, to participate in a demand response program, that's already a step forward in simply curtailing or meeting a demand charge, preventing a demand charge spike from the EVs. So that's already one challenge. Then the second step would be selling the power to the grid in a vehicle to grid construct. So there's a lot of, I would say, innovation money, R&D. The DOE has some money, but or EPRI has research funds there. But for now, it's a lot of pilots, and some utilities are working on it, but it's very much a learning stage.
Fantastic. Okay, so we only have a few minutes left, so I'd love to maybe wrap up with last words from all of you. While there's definitely seemingly, we all take for granted a little bit that, of course, there's going to be this swell of EV, and all of our projections, show that. We've also seen some lightening of interest in our own consumer data, and some of the auto manufacturers pulling back a little bit, right? And big concerns about whether the grid's ready for this. So would love to understand, maybe what your near-term outlook is, and if you have any thoughts to share with those in the industry who might not live in the EV space all the time and are trying to understand in a somewhat uncertain market what's planned for. I'd love to, start with John, and then I'll go around the horn here.
Sure, I can give you some thoughts on that. I know there was something in the news that talked about a slowing of the EV market, but all the data that I've looked at just recently, the numbers of EVs in the marketplace continue to grow at a record pace. Sales volume last quarter hit another record. I think this is 13 quarters in a row of EV growth. I think we hit somewhere near 8% of total industry sales in the last quarter of EVs, up from about 6% just a year ago. So I think we continue to see a pretty significant growth in the EV sector. And I think in order to continue seeing that growth, there's going to be a couple things that need to happen, right? I think what needs to happen is that in order for people to get over this anxiety of EVs, we're going to need, fast charging times, right? You don't want to have to wait 20, 30, 40 minutes. You want to have it similar to pumping gas. That's what people are used to. I think we're going to need long range, right? We continue to have longer range with batteries. That's going to be important. We're going to need the infrastructure in place. So important that you're not going to have to search for a place you can go and you can charge very quickly. And the EV costs need to come down. An EV vehicle compared to an ICE vehicle is about 10,000 more. So, long term, I continue to see this hockey stick up to 25, 30 million by 2030. I think in the short term, there's always some technology issues. I think there's always a weeding out of people who aren't necessarily committed or don't understand the technology enough. But you see a lot more car manufacturers now taking the big stage. Tesla dropped about 50% of the market, first time ever. So we're seeing a lot of other vehicles come into play from a lot of different manufacturers. So I think, while vehicles are here, I think there's still a lot of learning. I think a lot of people are still developing their plans to get into the market. So I see nothing but growth in this space.
Awesome. Thank you for giving us with those projections. We're just about out of time. So actually, Alex, I'm going to end with you and give you the last word here. So any thoughts for companies who are trying to understand the outlook on EVs and how to prepare for it?
Thank you so much. And it's a big responsibility.
Big.
I would actually like to talk about what I am excited about. And first and foremost, if you look even at this panel, we have an amazing lineup of companies, and that goes far beyond this panel, working on all the challenges we talked about. And it's truly exciting. The innovation does not stop, and that's what we need. That's terrific. I think there's one more aspect that we didn't even touch today, and probably could be a whole separate session. But that aspect is, what about utility companies? We talk about the grid, but they are the ones who run the grid. And we're seeing a lot of movement towards the understanding of the EV challenges, what kind of they bring to the grid, and what it will take to adopt all of that. And that's truly exciting. I think it will take quite some time, because we all know utilities move fast. Not fast, but slow. But that's only natural. And that's really excites me. And I hope this was a helpful panel for the listeners. And thank you so much.
Well, thank you all really so much for joining us today. We appreciate all of your expertise. Great variety of voices on this panel from different parts of the ecosystem. So thank you all so much. And we hope you join us for another session in the future.
Thank you.
Thank you.
Thank you. And thank you again to our partners for making Smart Energy Summit possible. And up next is our virtual session in January, which is, what to watch at Distributech. We're tracking industry trends and also really looking out, for the year as we kick off the year in January. And then again, we will be at Distributech. So on February 27th and February 28th, it will be our full 2-day conference in person, but we will be co-located with Distributech in Orlando. So we welcome you all to join us. And again, we do have submissions for speaking open. So look for our call for papers. If you're interested, again, I talked about some of Park Associates studies earlier today, but here's another one. We had a report out on solar and storage opportunities in the smart home, so you might want to check that out. And in addition to events and research, we also do custom marketing services based on our research, including white papers and webinars. So, and our podcast, if you're interested in getting in front of utilities or other energy players, we'd certainly love to work with you. You can reach out to Ashton or Jason or Mindy Sue, and we'll connect you with what you need. Thank you all so much for listening and looking forward to seeing you all again in the new year. Thank you.